Alright guys, I'm going to show you the dissolving process, and it may seem a little bit difficult at first, but once you get the kind of the idea, it's easy to understand for a lot of different types of salts. Okay, so we are going to, this is just a beaker, and in this beaker, it's going to be water. Okay, now, I'm going to draw a bunch of H2Os in here. Now, we know that the first thing that's happening in this sample of water is that these water molecules are moving around randomly. They're moving around, bouncing off each other, hitting the sides, moving around. So they're moving around randomly. Okay, now, if we introduced a solute, let's just call it NaCl. Okay, now, as soon as this salt enters the water, we know that these H2Os are moving around randomly, so there's definitely going to be some collisions. All right, so I'm going to make a little list here as I go through this. So number one, random motion. Okay. Number two, collisions. Okay. Now, what happens when the H2O collides with the salt is it's actually going to weaken that electrostatic force. Okay, so at NaCl, let's just, right, I'm just going to do it like this. Okay, so when the water molecules hit the NaCl a bunch of times, it actually weakens that bond. That's that electrostatic force, that ionic bond right there. Okay, now it's going to keep getting weaker and weaker and weaker, and eventually what happens, it breaks apart into ions. Okay, it breaks apart into Na plus and Cl minus. Okay, so Na plus and Cl minus separate. Okay, now, in order for something to stay dissolved, those Na pluses and those Cl minus, they have to stay separated. Because if they get back together, guess what's going to happen? They're going to reform back into NaCl. Just like that. Okay? So what water has to do is they have to keep them separated. Okay, now, how do they do that? That's the big thing. So I'm going to draw a little bit of a bigger scale here so we can see what's going on with the water. Okay, now, we know water, let me get a different color here. We know water looks like this. H, O, H. Now, we know water is polar. That means there's unequal sharing of electrons. And as a result, we know that the O side's partially negative and the H side is partially positive. All right. Now, I'm going to draw some more over here. I'm going to draw an H2O over here. Boom, 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 boom. Oops, out of the beaker. Okay. Boom, boom, boom here. And then I'm going to draw another one here. And another one. I'm going to raise the level of the water so I can get another one in here. Okay. And I'm going to do another one right here. Partially negative, partially positive, partially positive. All right. Now, these are just some water molecules moving around. Now, we know that we have a bunch of NAs, or NaCls, that have been bouncing around, getting collided with, and their electrostatic force has weakened, and now they've been separating the ions. So what water does is they form these cages around the specific ion. Okay, now, notice that the Na plus gets surrounded by the O part of the actual water molecule. Why do you think that is? Well, guess what? Na plus is positive, O is partially negative. So there's a force of attraction there. So it forms these shields around the opposite ion. Okay? If they keep those shields around the ion, guess what? As long as this moves, they move together, and this Na plus and the Cl minuses will not get close enough to reform that electrostatic force or reform that ionic bond. Now, can it happen? Oh yeah, it happens all the time. It happens all the time. Especially when you keep adding more and more salt. If you keep adding more and more and more salt, there's going to be more salt than the water can form shields around. So you will see some NaCl's floating around. And guess what? That's what it means for something to be saturated. Okay? If you saturate something, you've actually added more solute than a certain solution can dissolve. Okay? It's at its solubility limit. Okay? And we'll get into that later, but I just want to tie that in real quick. Okay? Now back to the dissolving process. Okay, let's recap. So the first thing that happens, we got our random motion. We have our water moving around randomly. Then we introduce a solute, such as, let's say, NaCl. That's really, really easy to understand. We bring in NaCl. Okay, now, the random motion from the water molecules, it breaks up that ionic bond. Eventually, it separates the two ions. So we have random motion, collisions, and then we have separation of ions. Okay, after that, number 4, we have the water molecules. So water forms, and these shields are called solvation shells around the ions. That's what happens. And it keeps them from bonding again. As long as they stay separated, guess what? Those have dissolved. Those specific solute particles have dissolved. All right? And that's the dissolving process.